All right, so we are back. All I did was take attendance in the gap that you guys missed. So we are now looking at Desmos, dealing with the Chapter 5 work. So when you come here, you can play with all this stuff, and this kind of shows you how to work with this. So play around if you want. I think there's a couple of videos, like how to Desmos sort of thing, or you can look them up on YouTube. But I just always go to start graphing, and it takes you to the window that is very, very similar to the graphing area of your TI-83 or whatever graphing calculator you have. So as earlier I was referencing parabolas. So the parent function of the parabola is y equals x squared. But I can move that parabola by adding something to it. So the really cool thing that Desmos has is it lets me say, I'm going to add some value of k. And what I can do with k is change it and see what happens as I change k. So whereas a standard graphing calculator, all you can do is type in the function and it spits out the function. Type in a new function, it spits out the new function. In Desmos, I can actively change what function I'm looking at in the moment. So what if k gets bigger? What happens to my parabola? So what do you think adding an integer does to a parabola? Shifts it vertically, right? Because if I add a negative integer, it's going to be below the x-axis. Now, what if, some of you might know this, what if I added a value in here? Ooh, a horizontal shift. So if there's an addition or a subtraction inside of the parentheses before it gets squared, that's a horizontal shift, and you can see that by just playing with this. If I move k, my integer outside, it shifts vertically. So what if I had x plus 2 squared?
Isn't it like the one in the inside, if it actually goes the opposite, so like for a positive, it goes
left. Yeah, so look at this. The horizontal shift, that's why I labeled it H, and really I guess I could have labeled this V. But this is counterintuitive. As my addition gets bigger, it keeps going more negative. So as the value that adds gets bigger, it shifts to the left. But my vertical does what I would think it does. As it gets bigger, it goes higher. As it gets lower, it goes further down. But my inside the parentheses is counterintuitive. If I want to shift it to the right, I have to add a negative.
And then if you multiply it, it scales.
Ooh, yes. So then, let's say I put an M here. That changes the steepness of the graph. And you can get really, really tight. And you can change the values of the sliders. I can click here and say what's my min and my max and what's my steps. Right now my steps are tenths. As you can see, it changes by the tenths. But I could get really, really precise. Now, of course, I could make these just numbers. If I wanted to make it 3 and 2 and 1, I can do that. And then it just shows me exactly what the graph would look like. So then let's say I want to see where that intersects with some line. Let's say I don't need these sliders anymore. So let's do a linear expression. So let's say we're trying to graph y equals negative 3x plus 2. So now I can change color over here, by the way. Turn it on, turn it off, edit all that stuff. I can zoom in and zoom out using my scroll wheel. I can grab the graph and move it around. And one nice thing is when I look for points of intersection, I'm looking for like where the two graphs meet up with each other. I can zoom way in, but one thing that I don't think this does, at least unless you have an account or unless you like sign up or whatever, it'll show me the point like just if I hover over it. But there's no, like there's a few things on the TI where I could like draw a line and trace it and do kind of some different functions that I don't think Desmos really has. So the function buttons for like when you get in there and you're doing like some of these zoom and trace features, that Desmos doesn't have, but it does most of what you need it to do. So if I wanted to find an intersection point, I don't necessarily have, like these functions are just to type things in. I guess I could find the length. So maybe I could find the minimum. Oh, no, that's probably a bad thing. Let's not do that. But yeah, let's say I wanted to graph like the sine curve. So then I can do like the sine of x, but I need a
sine curve.
Sine curve, yeah.
Like a sine wave.
Yeah. Okay, curve, wave, yes.
What does that value actually mean?
So that's really far. That goes too deep. Sorry, not
Too
today.
deep?
We've got too much to cover. So then, yeah, where does that intersect the sine curve? Well, I can see, oh, there it is. It can tell what I'm trying to do. Or where does my sine curve intersect the x-axis? Right there. So I can find out all these like great important things using Desmos. So is that kind of the basic runaround that you wanted?
Okay, that's easy. You can do that.
Turn graphs on and off. I thought you could edit the color. Yeah, here we go. You can edit in here. So there's a lot of things that you can do. Play around with this. It's fun. Oh, and I like that before it lets you close it, it's like, wait, are you sure? You've got work here. Are you sure you want to close this page? So yes, I do want to leave that page. Questions from chapter 2.
Yes.
What issues do we have? Jocelyn.
Okay, so there was one from this that said write a rule that represents the function. And
What
I was
lesson?
I don't know.
Was it in the
It-
notes or just on the
on
Oh,
the
sorry, you didn't process through all the lessons. So write a rule to represent a function.
Yeah.
In this problem,
They're so it always I don't know why it didn't start talking for you. It always starts talking for me.
It's
Um,
like from a set of ordered pairs, though.
From a set of ordered pairs. Ooh.
Number 5.
in this problem,
Quiet. This might work.
I thought we figured that out. No, we didn't. Yes, we thought we did, but then we feel and then I proved to you that it didn't work.
in this problem, you will write a non
Okay. I'm gonna pull up one of the quizzes because I know. So like, say you're just given 2 points. There's no like situation about it. Just gives you 2 points.
No, it gives you like a set of ordered pairs, so there's multiple pairs that they.
Let me see. Oh. Yeah. So I made a couple videos about that yesterday, but I can't remember if I made one specific to that one. Yeah, let me just pull up a quiz. Ah. So like these, right?
Yes.
So the biggest advice that I had to start with these, set up a table. Do not try to look at it how it's written like this, because it is hard for your brain to see any sort of relationship set up like this. So the first thing I would always do is set up a table. So if I look at number 5, I have x, I have y, 0, 5, 1, 6, 2, 7, 3, 8, 4, 9. Obviously, we're starting easy. But what do I see happening as I change every 1x? What's happening to my y? Yeah, so since it adds 1 for every x, I'm going to say it adds 1 for every x. So 1 times the x amount. But it can't just be 1x. It has to start somewhere, right? Where does it start? 5. Because when x is 0, what does y still have to equal? 5. So is anybody having issues with linear functions? Things that end up like this where the change is constant every time?
No, that's the one that I.
Yeah, so that type should be familiar. We should hopefully be good with that. I'm going to clone this page a few times actually so I can leave everything in the notes. By the way, everything I write up here ends up getting posted in PDF format. So you can check it out in the class notes page at your leisure. So let's look at 6 then. Again, XY table, so I can look at the changes. 0, 0, well I go through the origin. 1, negative 2, 2, negative 4, 3, negative 6, and I could do 4, negative 8, but I don't even need to. What do I see happening here? Every time I go up by 1x, what's the y doing?
Times negative. Oh wait. Yeah, was it times negative 2?
Not times negative 2, but it goes down by 2, or adds negative 2, right? So since that happens every time I change an x, I say y is going to be negative 2 times the x. Well, what is y when x is nothing? Well, y is also nothing. So plus nothing, or I just don't write anything. Your function there is just y equals negative 2x. Now our next one is still pretty easy. What about 1, 2? All right, let's skip to 8 because we want a harder one. So we look at number 8. 0, 1, 1, 2, 2, 4, aha, 3, 8, and 4, 16. What is happening here? Megan?
As x goes up by 1, y
So y is doubling. So first thing I always do is look for any addition pattern. So if I start looking for that, I have plus 1, plus 2, plus 6, plus 8. Obviously there's not a consistent addition, but then I can check the, what? Oh, sorry. Thanks. Everyone makes mistakes. So then, and this isn't going to matter here, but the next thing to look at is what's the change in the change? Is this second layer consistent? Well, I went up by 1 extra, I went up by 2 extra, I went up by 4 extra. That's also not consistent. If that was, this would be exponential. So if the change in the change, if the second layer that we look at here is consistent, that indicates an exponential function. Too bad this isn't, doesn't help me out. So, anyone have a good idea? Jada?
Can't you do like y equals mx plus b?
We can, yeah. So we're going to be in the y equals mx plus b form. We're assuming, so if we're going to be in that form, you're assuming that we're linear. Is this going to be linear if I keep doubling? No, so to do this, it would have to be linear. I know I'm not going to be in that form. So if it's not linear, we don't think it's exponential. How do I represent this? Let's play with values. Start y equals x, but leave a blank here, leave a blank here, and leave a blank out here because we don't know what's actually happening. Play with things till you figure it out. So what do you think? I know the answer, but it doesn't help you if I just give you the answer. The skill here is how do we play with the function until I find the answer? No answer is going to like jump out of the pages at you. It's try something, it won't work, try something else. What do you think?
Would it be 2x plus 1?
So if I try that, 2 times my 0 plus 1, that works for my first point. 2 times my 1 plus 1 works for my second point. 2 times my 2 is 4, plus 1 would give me 5. It doesn't work for my third point. So it works for my first two, doesn't work for my third, doesn't work out. But you're close, you at least met 2 of the points. Another thing you can start playing with is what about if I put something up here, but then again, that makes it an exponential function, and we said we don't think this is exponential. Because if I plug in 0 squared, well, that gives me 0, and that doesn't work. But if I add 1, well, okay, so 1 squared gives me 1, plus 1 would work. 2 squared gives me 4. Crap, it falls apart again. So if I don't have x in the base, what if I have x in the power? If x doesn't work as your base, think about what could have x as its power that might work here. Because if x doesn't work in the base, play with it in the power. Well, if I have, let's say, 2, because if I put a 1 there, it's not going to do anything as I change the power. If I put a 2 here, I say 2 to the x. Sorry. Gravity works. So 2 to the 0 power. What's anything to the 0 power? Guys, this should jump off the page at you when a function is being difficult. Anything to the 0 power is 1. This number could be 7,634. But to the 0 power, it's 1. Any number to the 0 power is 1. Have that be an indicator to try x in the power. 1. So 2 to the first power. Okay, that works. 2 to the second power. 2. This is what it is. This is my function. Because it works out for every single point.
Oh, now and the problem that they give you
Let's
on
do a
this
couple
one,
more. Yeah,
because
they're tough.
Because I didn't know about the exponential functions when I was doing this.
Yeah.
I do, so.
Let's do it. Those are fun. Guys, you laugh at that. I genuinely enjoy doing things like this. Well, a lot of people don't like their job, so you can't assume that all because it's my job.
The whole thing is you're supposed to find a job that you like.
Well, yes, I do agree with that. Let's look at quiz 2. Remember, domain and range are fancy ways to say x and y. Sequences being arithmetic. People figure that out. Arithmetic means it adds or subtracts the same every time. If it's not arithmetic, it might be geometric. Geometric means it's going to multiply by something every time, but we're not that far yet. Explicit and recursive. I think I posted a video about that yesterday. Pretty sure I posted a video in chapter 2 about explicit versus recursive. I remember working with it. Yeah, explicit and recursive formulas. So if you're at all confused on explicit and recursives, check this out. Any other chapter 2 question? Well, yeah, we can look at this. So this is exactly what we were just doing. So 0, 4, 7, 5, 2. These are all easy.
How would you show it using woods?
So say I can represent this with y equals 4x, right?
Yeah.
I could say the output value is always 4 times the input value.
Oh, okay.
There's your with words. Like, all you have to do is how, like, when I say y equals 4x, what does that mean? Well, it means the value I get when I'm done is 4 times the value I plugged into it. So however you would say that. I can pull up the chapter test, and we could do a couple more of those if anyone thinks that would benefit them. Anyone want more work with writing a function based off points?
Well, my question. Wait, hold on. Let me see.
I got a bunch more here if you want to do any.
Mine is more of the the range and domain, identify the domain and the range of each relation. That's like.
Yeah, so this.
Yeah.
So right now, my domain values are -3, 0, 1, and 2. And my range values are 6, 2, 0, and -3. What I want to do is to determine whether or not it's a function, I got to figure out, is there a rule that represents these points? If not, then it's not a function, and my domain is these 4 points, my range is those 4 points. But they're values. But I hope that there's a function that represents this. So let me put that over into Smart Notebook. So again, XY table. look for anything arithmetic. Subtracted by 4, subtracted by 2, subtracted by 3. Well, that's really awkward. But notice we weren't going by 1 every time. This went by 3, then it went by 1 and by 1. So when we went by 1, I did -2 and then -3. But back here, the fact that I started with a -4, that's really awkward. If I just look at these two, well, this became 1 more than what it was. But I can't, there's like no consistency to really see the rest of it. So if I can't write a rule, this looks very, very complicated to write a rule. I only have 4 points. It's not enough to go on. So how else can I check if something's a function? What is my rule that lets me see, is this a function?
Can't you go like behind?
What do you mean behind?
I would say like before, rather than like starting like x equals to -3 and y equals to 6, you can do like before what happened.
But I don't know any of those. Because I don't know the function rule, I can't determine any of my other points. I like that idea, I can't, because I don't know the rule. If I knew the rule, that would be perfect. How do I have you guys checked functions on graphs? There's one really, really common way that we check functions. Yeah.
A linear line test.
Yeah, the vertical line test, right? What is the vertical line test?
Is it something like something with you take it across and check?
Caleb?
It's basically, so if you have the line on a graph, and you basically, I mean, it doesn't have to be a pencil, just it has to be in some object, or it can be just an imaginary line, and you take it and you try to like bring it across the graph. If there are two x value points that are on the same, like if you look at it and there are two x value points on the same thing,
Same line.
If two inputs have, or if two outputs have the same,
x value,
Two-
and
two outputs share the same input is what you're trying to say. So I've talked about parabolas a couple times, and you guys are going to get to those later in your math career. So here's the two most common parabolas. Y equals x squared and x equals y squared. One of these is a function. The other one is not. It's just a relationship. Brian?
The red one would be a function and the blue one would not.
The red one is a function and the blue one is not, because when I draw a vertical line down my graph, this is why it's called the vertical line test, I see that the input value, let's say of 4, and actually this is what's really cool about Desmos too, I can have Desmos do the vertical line test for me. If I want a vertical line, I want an x equals, so let's say x equals 4. There's my vertical line and I can check it. I've got two output values sharing the same input. This is not a function. So I check my inputs and my outputs. Are any output values sharing the same inputs? No, nothing shares the same input values. So should this be a function? Yeah, this should be a function. So my domain right now, I could just say my domain is this list right here. My range is this list right here. From what I know, it is a function. That from what I can determine, it is a function. Yeah, and that's exactly, so, and have you guys learned about like set notation? Like if you have a set of values that you're trying to say, like if I wanted to write out my domain is these values, do you guys know how to do that? You can say domain, and then, is this a colon or a semicolon?
Colon.
People always fight about that.
Semicolon has the semi.
These are hard to draw, but they are what we use. Not parentheses, not the boxy brackets, but we use these squiggly brackets, which you'll get better at the more you do it. We say the domain is -3, 0, 1, and 2, another squiggly bracket. And the range is 6, 2, 0, -3. It is a function. From what we know, it's a function. Now, they could give us a fifth point that then makes it all fall apart, but from what we see right now, it is a function. Any questions on why? I'm going to walk through 16 also.
Yeah, well,
So, if I put these points on the graph, let's just go ahead and do that. So,
wait, never mind. Because none of this inputs are the outputs, right?
no input is shared. Really? So that's the big, like, if you want to simplify it all the way down, if an input is shared, not a function. Functions do not share inputs. They're very possessive. Dated a function once. I was going to try to make a joke, but I don't know where that's going. How could that?
You dated a function once.
She
used
was.
to have like a right eye.
No, yeah, what? How could that be funny? I'll think it up.
You
I'll
used to
post
have
it.
lips.
Have you ever Google like bad math jokes? There's so many good ones. I say good because I think they're hilarious. John made a really good pun yesterday. We were talking about this piano player, and I forget how we got John over here, because he was in here working. I was showing him this piano dude that I like on YouTube, and he was like, "Well, I guess that's the key part of his page, the keys on the piano." It's so good. I love it. Okay, so I like to look at these in a table. So if I do 16 now, ignore 15. If I do 16 now, I'm still going to XY a table. Even though I'm not looking to write the function rule, it just helps me look at it. -1, -4, 0, 0, 1, 4, and 2, 8. And actually, this one, I could write a rule to represent this. What's happening to my y every time I go up by 1x? My y goes up by 4. So I could say y is going to be 4 times the x value. Well, where's the intercept? 0. So this is actually my function rule. So this one's easier to see. It is a function because I can write a rule for it that would work. It would be a linear graph that obviously would pass the vertical line test. But if I still need to write out the domain and the range, domain, fancy bracket, -1, 0, 1, and 2, just list all those values, and range, fancy bracket, list all your y values, -4, 0, 4, and 8, fancy bracket, and it is a function. Sweet, that's what I like to hear. Not only is it a function, but it's a nice, easy, linear function. Alex?
If we're gonna move to chapter 2, I have a question.
Why?
Chapter
Hold on.
2.
Any other chapter 2 questions? Yeah.
Find the range of each function with a given domain. So rather than
Find the range with a given domain. So, like these?
Yeah.
Yeah, because I'm on a different form of the test, just because I don't want to give you guys answers. We'll just grab the first 2 for right now. All right, so this is a lot easier than you think it is, and I'm going to show you how we can use a graphing calculator to make this super duper easy, but then I'm going to show you the other way too. So, my TA84, let's see if this works. I've been wondering if this would work out anyway, so this will be a good test. This is when a graphing calculator really can just make your life easier. It's not necessary, but it will just make your life easier. Maybe. Yeah. Okay. So, I can go to my y equals menu.
Wait, it has a touch screen.
No. So I can go to my y equals menu, and I can actually type in that function. So if I check back to what my function was, -2x plus 1. So I type in -2x, make sure you use the negative and not the minus, -2x plus 1. Then I go to my table set menu. So it's the second function of window. It's table set. I need my independent to be ask so that I am going to determine the independent variable, which is the x variable, and the dependent variable, which is the y variable, is going to be auto because it's going to happen on its own. I then go to the table and I'm going to type in the values that it told me to type in. So I'm actually going to delete all of these so I don't get confused. If I go to the input values that they told me, -2, 0, 2, 4, and 6. So, -2, 0, 2, 4, and 6. All I'm doing is plugging in those x values where the x in the function was, and then these output values are my range. Because if this was my domain, these are my range values. So then I would list out, and I'm going to drag this up here. If you're watching at home, you won't be able to see that now. I'm just going to list out then the range is 5, 1, -3, -7, and -11. Now, that's the shortcut easy way if you have a graphing calculator. Obviously, not all of you have a graphing calculator. So what if I don't have one? I'm not going to go buy one. Desmos, I don't know if Desmos has that function or not. So all I would do is look at each situation. Instead of f of x, I now know what my x is. If x is -2, in function notation, this is saying the value of the function with -2 as the input. So to do that, I change my x to a -2. When I solve that, that's going to be 5. That's going to be my first value in the range, because -2 times -2 is 4, plus 1 gives me that first value. The next one, I would just evaluate f of 0 and plug in a 0 everywhere I saw on x. So -2 times 0, plus 1, gives me 1, which was the next value that I got from my calculator. So all you have to do is plug them in. Really, when it says evaluate the function, determine the range, just plug it in. Do I need to do another, or do we get that now? Cool. Other chapter 2 questions. Okay.
Well, this is an open-ended one, and it says write an example of a sequence that increases in pattern but is not an arithmetic sequence. Or however.
So, if it's not arithmetic, that means that it's, and I don't even need to pull a question up like that. So we want a increasing but non-arithmetic sequence. So it has to follow some kind of pattern if it's a sequence. So what if I start with the value? Let's say our initial value is 2. What could my next value be?
Like 4.
4. Don't make it 5, and here's why. If I want to look at this being non-arithmetic, you cannot look at this as addition or subtraction. It has to be multiplication or division. So what's my next value? And my next value? It's that easy.
I just don't understand.
Yeah, exactly. So it's all about like interpretation and understanding. So I'm glad you asked that. It's not a difficult concept. They're trying to lead you to the idea of a geometric sequence. So if something doubles in size every year, like there's certain trees that double in size every year, or things like that, that is represented by a geometric sequence as opposed to arithmetic. Other chapter 2 questions. That's enough wait time to make it awkward. Going once, going twice, message, email, text, call, anything else if you have any other issues. Be happy to help you. I should close this because it's killing my RAM. All right, moving on to chapter 3. And I should probably save this because the power went out randomly yesterday.
Really?
It was very sad, yeah.
How does it
Oh, you know our building.
Yeah.
Come on.
It never went out, like, just in randomly in the
Yeah, it
middle.
Yes.
Yeah, remember it just went out. It wasn't even, it was just like, it was a nice day. And
Remember, like, when Mr. Roman...
Also, the internet kept dropping yesterday. Don't know why on that either.
The internet
All right, so chapter 3. If I go back to our resource page, all about linear functions. So hopefully you've had a good amount of work with this between 7th grade, or like Math 7 and Math 8, that these were at least familiar. But some of the areas where people are going to get stuck is point slope form, standard form, and then parallel and perpendicular lines. Maybe absolute value functions. So I'm expecting questions from this area. I mean, if you have questions from here, I'd love to take them. But I'm expecting and hoping probably some of you have some questions here. Yeah, so Alex. What's your question?
Point slope form.
Point slope form. So this is when you could go into here, look at the lesson, and go to the key concept. So if I go into instruction and I click on my post-it, here is what point slope form is. So whereas your y-intercept form is a y equals mx plus b situation, what we have here is one point and the slope. So I'm going to plug in y minus the y value that I have from my point, the slope I know, times x minus the x value that I know. That, when I distribute the slope and combine the constants, if I manipulate it to get it back to point slope or slope-intercept form, it'll be the same line, whether I graph it in point slope form or whether I graph it in slope-intercept form. So then that's what we use if I know one point and the slope. Or I can go from there and find a second point. Like, I can do a lot of things, but point slope is used when I know a point and I know the slope. So that's the point slope form.
Is that how you write it when you figure it out, or can you write it in like normal, like how would you write it?
So you would actually write it like this. So the weird thing is these are both minuses. So if you have a negative value, it becomes positive, which is why this turns into x plus 3, has a slope of -5. The point that I know is -3, 6. So since that's the point that I know,
If you're subtracting a negative, would you just do the, add?
yeah, it just turns into addition. So that's what happened here. Minus the negative turned into the addition. And then this is just how you leave it. I know it's messy, but if they ask for it in point slope, that's how you leave it. Now I could then, this is the funny thing, because I like slope-intercept form a lot better, distribute the -5. So I get -5x minus 15. Combine your constant values. So I would add 6 to both sides. Slope-intercept form. So you can go from point slope to slope-intercept and vice versa. To go from slope-intercept to point slope, you just have to factor. So you have to figure out what, it's harder to go from slope-intercept than it is to go to slope-intercept, because to work this process backwards, I have to figure out what could be factored out and get rid of a constant first and then factor, and then I get back to point slope form. But that's really, really kind of hard, and we don't normally ask you to do that. But to go from point slope to slope-intercept is easy. Distribute, combine. Other questions? Or, I mean, do we need to do more with point slope? I'll do another.
Do we
Gonna do another
need to
example?
write it as y equals mx plus b, the point slopes? And the
No, so if it asks for point slope, you leave your answer like this. I was just showing that you can easily go from point slope to slope-intercept.
Okay.
Because I like this better. But this would be nice and easy to graph it. Start at the point, -3, 6, and then take the line going on the slope of -5.
So
But if we want go
so
ahead.
if they give you 2 pairs of like points,
2
like,
points. I actually posted a video about that yesterday. But you can determine the slope first,
okay, that's
and then
okay.
plug it in. You can choose one point to plug it in.
For the questions that ask you about just find the slope and y-intercept, is it really just find the slope and y-intercept?
Yeah, so it's that easy. It's just determine what the slope is and determine what the y-intercept is. So if my line passes through the point 8, -4 and has a slope of 2/3, I know this is my x, this is my y, this is my m. So I know point and slope. I always write out everything before I plug anything in. And I don't like to toot my own horn or anything, but I think one of the ways that I got good at math is being so thorough. If you always start with a generic form, it will help you remember it, because the more you write it, the more you're going to remember it. So the more times I write this down, the easier it is for me to remember y minus y1 equals m times x minus x1. Then I plug in. So y, I can barely see that, y minus the y value that I have, m, my 2/3, times x minus the x value that I have, 8. Now I simplify. And I'm done. That's it. And I know it's not pretty, it doesn't really, but that's point slope form. That's why I don't love point slope form, but it's useful. By the way, there's also a big old poster back there. Once we break up from group work, if you still have confusion, that poster's pretty useful. Yeah.
Once again, in the test, they gave us 2 points and not the slope.
Yeah, so I'm actually, this is fun.
Can't we find the slope from 2 points?
Yeah,
You can.
that's what I did.
That,
Y equals mx plus
to encourage you guys using Schoology, I will walk you through how to solve one of those problems. But I'm going to time travel. You guys all know how to time travel, right?
Oh yeah, certainly you walk backwards.
You got to make sure that you have eaten a good breakfast before you time travel.
What?
If you're going to time travel, you got to make sure you eat a good breakfast.
It's good to know.
If you have to ask, you'll never know.
Is that a Doctor Who joke?
I do like Doctor Who. So,
That sounds
this is
like
how I'm time traveling. By the way, if you're in Schoology, it doesn't let you full screen. Oh. Well, yesterday it wouldn't let me full screen.
Did you know
As
the
you
sunrise
say
is a
that.
mirage? You're actually seeing the sun come up 2 minutes earlier. And it actually. Why I know that is not important.
So, the big thing to remember about slope, if I can write this, I encourage headphones, is that we often call slope our m value in those equations, y equals mx plus b. But what it's really representing is the rise over the run, which the rise is our delta y, or our change in y, and the run is our delta x, or our change in x. So here, number one, we want to find the slope between these 2 points. We can set up that we want Rm, and we're looking for delta y over delta x. But to find our delta y, we do y2 minus y1 over x2 minus x1.
This is what I mean about writing out the whole process.
Y2 and x2 and all that stuff. It's just meaning which point is your first point and which point is your second point. So I'm just going to take my points in order and say that that point on my left is my first point, and 8, -4 is my second point. So then I'm going to plug in the value. So y2 would be the y value from the second point. Sorry, not comma, minus y1. Then x2, my x value from the second point, minus -2, my x value from my first point. Ignore problem 2 for the current time. -4 minus 5 gives me -9. 8 minus a -2 is actually going to give me a positive, or turn into addition, because minus a negative turns into addition, because it's the opposite of subtraction, or the opposite of a negative. And that gives me -9/10, which if I would want to write as a decimal, I could write -0.9, and sometimes I put my negatives up high on the number. I'm going to do that again just so you guys can see it. So I sometimes put it like that so that it's further away from my equal symbol. That's all up to you, whether you put it right in front or a little bit higher. But my slope there would be -9/10. I could leave it in the fraction form if I wanted, or I could write it in decimal form. Depends on how you like to see it. So, if, especially if this was a challenge for you, try number 2 here for a second. I'm going to grab some coffee, and then I will be back to talk through coffee. It's like the lifeblood. So, from there, we can find our equation and this video does just that.
Wait, before we start this video,
Yeah.
I have a question.
Which actually, I can just, like, I was just making you guys aware that, like, it's funny that you're asking the question that there is a help video already posted. Yeah, what's up?
Okay, so.
I'm not going to show you
What
any videos
is
today. That
a
buzz
direct
kills me.
variation equation?
Direct variation just means it's a proportional relationship. Do you remember what proportional relationship means?
Was that something like, is it changes, it's always changing the same?
So a direct variation equation is an equation where y varies directly to x. So direct variation means that y varies directly related to x. So what that really means you're just going to have a proportional relationship. It has to,
So just y equals mx?
well, there would be a value for m, but it has to be a straight line. That's why I know that I have to use the y equals mx form. And has to go through, anyone know? The origin. So direct variation, same thing as proportional relationship, just a new name for it. If something is proportionally related, that also means it is directly varying, or will directly vary. All right, other chapter 3. Do you want me to then show how we go from finding the slope to finding the equation? You guys are fine. I'm just asking. So that video that I showed, we found the slope. From there, we have to be able to make an equation on some of those later problems. Does anyone need to see that? All right, what other chapter 3 questions do we have? Good. Close that window. Anything else from this list that held you up, gave you some trouble? Check now.
Slopes of parallel and perpendicular.
Yeah, so parallel and perpendicular lines are, I'm actually going to start a new video for this because this video is getting so long. So if you're watching at this point, I'm just going to hop over and I'll probably name this slopes of parallel and perpendicular lines or something similar.